And welcome everybody to the Daily Space Weather. I'm full of it, and when I say it, I mean space. Yes. Yeah, we've got a new background. It's still the constellation Cygnus. And let's take a look at some space weather, shall we? That's 24 hours of action from the closest star. And the most active region has indeed been that sunspot in the northeast. Pretty sure I said yesterday I would expect that one to be the most active sunspot, and indeed it is. Here's an extreme close-up for your viewing pleasure. These 24 hours depict SDO 171 angstrom 60-minute running difference along with 131 angstroms. And we've got some more imagery to show you here. We're going to come back to that momentarily. First, a brief look at sunspots. That group in the northeast has grown a little bit since yesterday. Besides that, mostly stable, a little bit of growth in that group to its south also. Not a lot of other changes, but mainly an uptick in sunspots for the past 24 hours. There's the SDO colorized magnetogram as well. And let's briefly take a look at what's going on with volcanoes. New map drawn for Grindavik. Most places alert levels have been dropped, although there are some conflicting reports about ground deformation. So still could be seeing some new volcanic eruptions about to happen, or it could be settling. It's just, you don't know. These are volcanoes after all. Anyway, here are the rest of the erupting issues. The list includes Suwanosejima, Luatobe, Merapi, Popocatépetl, Santiaguido, Fuego, Nevado del Ruiz, Sangay, and let's don't forget Sabancaya down in Peru. As far as earthquakes, this is what's been going off for the past 90 days. And here are the past 24 hours, a lot less active than the previous 24 hours. These are the quakes of a 5 and greater magnitude. Argentina had a 5.4 early this morning. And then a lull in 5 and greater magnitude activity until late this afternoon at Colombia, a 5.2, and then a 5.1 down at Chile, placing all of the 5 and greater magnitude quakes on the continent of South America. So let's get back to some space. There's another 24-hour video. We will come back to this when we get to our CMEs and filaments section. Let's briefly take a look at some close-ups in these wavelengths. Now we're showing 193 angstroms 60-minute running difference along with 304 angstroms raw ultraviolet imagery. Cool looking filament over here in the northwest. Slowly setting there, now becoming a prominence. Still visible at the moment. It is still attached. But again, this is where the real action has been taking place. This large and growing sunspot group, as it moves into the Earth-facing zone of that northern solar hemisphere, becomes more and more interesting and more likely to produce or be associated with massive earthly directed coronal mass ejections. There's a fantastic close-up for you featuring all kinds of different things happening. Some flaring, some Hyder flares, some filamentary ejections, some filamentary reorientation, and some plasma filamentary collapse. And before we get to coronal holes, let's talk stats. The 10.7 centimeter radial flux is now back up to 179. 179 is the F107, folks. There's the 1-year graph of the radio flux. Red line is the sunspot number. Black line is the F105, the F107, the 10.7 centimeter radio flux. NOAA exactly agreeing with our forecast. We cited that there was going to be 2 CME impacts, and that's exactly what NOAA's forecasting. So there it is, coming sometime after midday tomorrow, and then up until late in the day on Tuesday. So 2 CME impacts coming. The second should be more extreme. KP6 is what NOAA forecasted, and I could not agree more. Exactly what I was saying to our viewers. Next, we'll look at Earth's magnetic moment from space. Let's stick with that view. I like that view. And yeah, it makes things easy. There are the past 4 hours of magnetohydrodynamic pressure. And things are calm when we do have those CME impacts tomorrow. Sometime around midday, we're expecting the first one to arrive. You can expect some major signals because we've got very weak solar wind for an extended period. So that's the past 4 hours of Earth's magnetic moment from space. Essentially what a proton experiences. Here's Earth's magnetic moment from the ground. A model of what your magnetometer would be likely to experience if it was at the surface level. So this depicts magnetic flux density, the units of which are nanotesla. Changes to Earth's B field, or geospace delta B. KP index at 1. Geomagnetic calm, not to continue for long. Within 24 hours, we should see geomagnetic storm. Next, we'll show the ACE and Discover. Yeah, the ACE and Discover. First, the ACE, which is showing very diffuse solar wind, less than a half a proton per cubic centimeter, and kind of slow too at 377 kilometers per second. The Discover, a little bit faster there at just under 400 kilometers per second for the velocity, and the density also much higher at about 3.5 protons per cubic centimeter. About 7 times the density there at Discover. GOES magnetometers are smooth. Expect to see some big sawtooth patterns in these. The telltale sign of geomagnetic storms. Next, we'll look at the heliosphere. There is the sector magnetism as Earth remains in a south pole magnetic sector, depicted there in red. Here's our solar B field, photosphere magnetism, and polar fields in red and green for south and north. Our line of sight field plot, one of the most data-rich resources you could possibly look at. That's the past 4 days, showing you a lot of stuff going on all at once there from the National Solar Observatory. Next, our line of sight coronal hole plot, and we've got a mix of north and south pole coronal holes. South pole in the east, north pole in the west. And we'll show the SDO once again. There's the SDO, and let's get a little bit closer there. And not half bad. Now that we've done magnetic fields and coronal holes, let's get to sunspots. Sunspot number back over 160. It's at like 162, I'll say, 161, 162, something like that. And here's our synoptic map. Take note that there is a 10% possibility of an X-class solar flare and about a 40% possibility of an M-class solar flare just from 3559. 3559, it remains a sunspot to watch. And let's take a look at sunspots from SDO. First, the magnetogram on the HMI instrument. So, mainly only growth in the past 24 hours, not a lot of decay of sunspots at all. Here we've added 171 angstrom 60-minute running difference imagery to that. Next, we will swap out the HMI's continuum for the magnetogram. And now we'll drop the 171 angstroms 60-minute running difference to just show the continuum. So a little bit of growth down here, modest growth down here, and modest growth up here. So if the trend continues the way it has, we should see another uptick in sunspot number tomorrow, as there's no chance of any new sunspots setting between now and tomorrow's video. Could be another uptick in sunspots. And let's get to energetic particles. We ain't got none. The GOES proton flux remains at baseline levels. The GOES X-ray flux here showing an uptick, and that is sunspot 3559 up there in that northeastern quadrant, producing some decent-sized C-class flares, a C7 or 3. Also a long-duration double peak there early this morning. Let's take a look at flares. There is the 131 angstroms. And again, note sunspot 3559 up there in your upper left is indeed the T-mass, or the most active sunspot. If you were hoping for some closer views, we got you covered. And I think we've definitely showed some pretty sweet images tonight, wouldn't you say? Let us know in the comments and tell us what you think. Here's as close as she'll get in 94 angstroms. And you can see those multiple C-class events there coming from sunspot 3559, our most active sunspot. At least the most active one on the Earth-facing portion of the solar disk. So that ain't half bad, right? And let's get to a star chart. Show some more relaxing stuff, shall we? So this is what's going on overhead right now. You've got the Moon and the Jupiter up there. You've got Moon and you've got the Jupiter. There you go. Also, Saturn is setting over there in the western ecliptic. Next, your solar system forecast, brought to you by the Smash News Network, least busted name in news, and theplanetstoday.com. Here's your 1-week forecast for the solar system. As Earth moves into this lonely side, the side devoid of gas giants. Have you participated in our Ask a Particle Physicist segment? Well, we do it for people just like you so that you have a chance to ask questions. Now, of course, I have a limited amount of time that I'm ready, willing, and able to spend on answering viewer questions. So, but at least once a week, we ask a real particle physicist some questions, or a question. If you'd like to submit your own, head to smashomash.com/forum. If you scroll down to the General Science Forum, there is one in there called Ask a Particle Physicist. So if you check out that topic, there you go. You too can ask a particle physicist a question, and we will then pose that and air it on the Friday edition. We've also got a new playlist, and by the way, the Smash team gets that latest edition of the Ask a Particle Physicist segment by itself. In other words, it only exists on Friday in the daily space weather video, and then up until the next week, it's not on the playlist yet, and then the next week, the new video comes out. It's only on the space weather video, and then it's on the playlist. Anyway, Smash Team gets access to that a little bit earlier. Let's take a look at the astronomy photo of the day. The astronomy photo of the day is Berserk. That is a utility pole that is covered to the top, almost, with snow. It's the blizzard of 1936. 1938, I stand corrected. The Upper Michigan blizzard of 1938. Where, yeah, that's That's quite a bit of snow. Snowdrifts reached the level of utility poles. Nearly a meter of new and expected snow fell over 2 days and started 86 years ago this week. The snow fell and gale force winds piled snow to surreal heights. Many roads became not only impassable, but unplowable. People became stranded. Cars, school buses, and a train became mired. Even a dangerous fire raged. 2 people killed, and some students were forced to spend several consecutive days at school. The featured image was taken by a local resident soon after the storm. Although all of this snow eventually melted, repeated snows like this helped build lasting glaciers in the snowy regions of our planet Earth. Anyway, moving right on to CMEs. And we've got some custom videos once again today. First, George Mason University's running difference imagery along with the raw coronagraph on the right. And it looks like we may have some more earthly directed components here. So another one likely to show up on the 24th, it certainly looks like. Maybe even 2 more CMEs. Yeah, pretty sure at least one of those is another earthly directed coronal mass ejection. So that's good news for all you aurora chasers out there. And let's take a look at our custom coronagraphs. There you go. There's a 24-hour video, and we'll show you the filament release as we zoom in closer and closer to the SDO imagery at the center. Not bad. Not bad at all. So right up here you'll see a filamentary release from Sunspot 3559. Also, it looks like an event coming from down here again. So, again, multiple CMEs there. At least one of those, possibly even 2, may be earthly directed. So, CMEs to start arriving sometime midday tomorrow, Monday, January 22nd, 2024. And to continue through the 24th. So at least 3 CMEs now likely to be on the way. And like I said, I was going to zoom back into that full disk image. So there you go. It is the 193 60-minute running difference along with 304 angstroms ionized helium. Good stuff. And let's cut to filaments. It's filament time. And look at the size of this filament in the southern hemisphere. That filament is absolutely berserk. That is getting a name at some point today. If you want to beat me to it, you can name that over on X. Name America's favorite non-game show. Name that filament. That one is a good one. That is a classic. One of the largest and densest ones we've covered on the channel. And pretty sure it ain't got a name yet. But it's gonna have one. Warp my merds. Dag. A lot of big plasma filaments right now in the Earth-facing portion of the solar disk. Before we get to bonus features, we'll show the latest. And like I said, that prominence now, we showed it becoming a prominence and some epic close-ups of it. And let's get to bonus features. The first bonus feature is satellite charging hazards. We ain't got none. It's smooth sailing. Goes electron flux here coming up off the floor a little bit, but not so much. It is very quiet as far as relativistic electrons in the F layer. There's the 1-year graph, and it's the longest electron shortage we've had all year. Forecast model there for flat levels, although I would expect these to get a little bit lower, anomalously low, in the coming days. That will be as a result of CME impacts, puffing up the ionosphere and creating those anomalous readings that I just mentioned. Next, we'll show the layer where it's measured. The F layer. Yeah, the F layer. It's at about 300 kilometers of altitude. And here it is in its vibrational frequency. So that's what's going on at the bridge between Earth and space. We like to show the anomalygram as well for our newer viewers. That first imagery might be Greek to you. There's anomaly in megahertz from a 30-day median. So this helps us to adjust for time of year. And of course, the solstices are actually the least geomagnetically interesting period. We're actually ramping up to a more interesting geomagnetic period now. The time around the equinoxes is the best time for space weather storms. We'll also show the WAM. But we won't wake you up before we go to the final portions of the space weather video and get to meteorology. We'll just continue on at a steady pace. So there's what's going on. Let's briefly show the naughtiest sunspot. There it is, sunspot 3559. It's pretty epic. And I don't know, it looks like it's degraded to me for the past couple of hours. So that one might be breaking down, but at the moment, it is also our TMAS, the most active sunspot. And moving right along, it's time for meteorology. So, what do you got? Well, I'll tell you what we got. We got the coldest place in the world, right there. There it is, the coldest place in the world. Anybody like to place a guess? Where do you think the coldest place in the world is, folks? Siberia? Antarctica? Chicago? Nope, it's Greenland. And Greenland has a very large contiguous area of about negative 50 degrees Fahrenheit. So this whole area here, 48 below zero. There we go. There's a 49.4. Getting close to 50 below zero there. That is the coldest part of the planet. A little colder than Siberia and a little bit colder than Antarctica. Anyway, that's surface winds and temperatures. Here are just surface winds. Quite windy there in the western Pacific. There are the jet streams of the eastern world, jet streams of the central world, surface winds of Europe, Africa, and the Middle East, surface winds of the west, and the jet streams. Jet stream convergence happening there in the north central Atlantic. Next, clouds and fog. That's what's going on over the Americas as far as 3.9 micrometer infrared radiation. And let's take a look at the Pacific. The eastern Pacific, it's been delivering a lot of moisture, and there's a lot more just about to get to the Pacific Northwest as a bunch of moisture trails that low. It's now made its way out to sea a little bit, but it's still loitering off the coast of Oregon. So some heavy moisture there making its way into Northern California. As we make the video, you see those high cloud tops. That's the visible satellite, by the way. And here's our precipitation type map, and quite a bit of rain here. Mostly rain falling in the U.S. at the moment, but there is some wet, heavy snow and some ice actually showing up in Montana and North Dakota especially. Also Oregon and Washington seeing a little bit of ice. There's the full map precipitation type from windy.com. Here's our weather.gov map. Weather.gov is where to see whether or not you've got warnings. Whether you've got weather, weather.gov is where to get the warnings. Next, forecasts, and we're doing GFS 72-hour forecasts. Another major ice storm here going to show up. Check it out. Starting in Oklahoma and making its way to the northeast, a major ice storm, folks, going to sweep across the country. Freezing rain. Freezing rain. Alert. That is a pain. Accumulated positive snow depth change in inches. The 72-hour GFS model. I won't try to explain it. That's where the snow's going to be. Ta-da! Next, total accumulated precipitation. And look at that. Texas is expecting over 6 inches of rain in some isolated areas. Over 6 inches of rain in Texas. And just a quick reminder, never try to sneak up on a dragon in its lair. You will fail and not surprise said dragon. Yes, that is my Chinese zodiac symbol. Last but not least for our Tropical Tidbits forecasts is the temperature anomaly forecast in degrees Celsius. Based on the GFS 72-hour model, we show these because they're accurate, and a bunch of warm temperatures coming to the northeast. In fact, from the Mississippi Valley on east, it's going to be anomalously warm in the coming couple of days. Might make it a little bit more hospitable to go out and take some videos and photographs of the Aurora Borealis when it shows up at mid-latitudes. I'm excited. What about you? Next, lightning. And we ain't got no lightning over the lower 48. Mexico, Brazil, but not the U.S. And here's a real-time lightning map, and yeah, quite a bit of lightning here, like south of Saltillo. That's where the strikes are. And it's been pretty calm as far as lightning strikes. We'll close out the video with U.S. Doppler. Some of that moisture is already making its way to Northern California. Eeks. Eureka. Putting the eek in Eureka. We'll focus on the lower 48 and close this mother out. Vertical motion in the air column depicted by ground-based Doppler radar systems. Space-based systems depicting clouds and fog even when it's too dark for the visible satellite. The shortwave radiation map. Water vapor showing the moist air, the dry air, and everything in between. Scattered moisture making its way across the U.S. in all kinds of funky different patterns. And here's your recap. Some lake effect snow does continue, especially east of Erie. Clouds and fog. And there is the water vapor map, and here is me signing off. I've been your host, Dan, a.k.a. Smash-O-Mash. And until tomorrow, may that solar wind be at your back. Whoa!